Hi everyone, welcome back to the channel. I'm Stuart Campbell, the Principal Consultant and Coach at Fig Technology Solutions. Today we're going to be looking at something a little bit more technical around how to manage remote state for Terraform without needing to spend a bunch of money on a cloud service. In order to do this, we are going to make use of the OpenTofu project, which was forked from the original HashiCorp Terraform project after HashiCorp changed their license. Since the fork, the OpenTofu project has joined the Linux Foundation, and earlier this year was accepted into the Cloud Native Computing Foundation as a sandbox project. This ensures it will remain open source and a key pillar of cloud native computing for the foreseeable future. OpenTofu itself is designed as a drop-in for Terraform 1.5 and 1.6, so it's pretty simple to migrate to, but we won't be covering that today. Being able to manage state remotely and ensuring that it is secure is a critical part of being able to use an infrastructure as code tool in a production environment. Without a single source of truth for the current infrastructure, it becomes very difficult for multiple users, including any CI/CD pipelines you have, to collaborate and manage your infrastructure. In OpenTofu, this is done through remote state. To quote the documentation, with remote state, OpenTofu writes the state data to a remote data store, which can then be shared between all members of a team. The other very cool feature of a remote state is the ability to share outputs with other configurations, enabling much more decomposition. We won't dive into it today, but the Terraform remote state data source can be used to do this. In order to set this up, we're going to make some changes to our very old now original demonstration repo for Terraform to allow our state to be stored in an AWS S3 bucket. Let's start by making sure we have the latest version of OpenTofu. On my Mac, this means using Homebrew to check if I have the latest version using brew upgrade OpenTofu. And we can see there that the latest version is installed, 1.10.6. I also need to check that the Terraform setup is compatible with this version of OpenTofu using a series of commands against the repo. We'll start by checking our tofu version is the same as what we should have installed, which it is, 1.10.6. We'll run an initialization against the repo to check any of the providers and make sure everything's up to date there and it's all working as expected. And then we'll move on to tofu plan to make sure that everything I've got configured is going to work as I expect. And there we go. We can see there that we've successfully managed to generate a plan. So everything in the repo is set up and migrated to use OpenTofu. Now that we've confirmed that, we also need to set up the S3 bucket that will be used to store our state file. So then the question is, how do I create the infrastructure to support creating my infrastructure? In order to prevent a recursive loop of state storage, at some point you will have to accept that we need to create it manually. You could have a separate Terraform file that uses local state, use a CloudFormation template, or just create the bucket manually. Depending on the trade-offs in your environment, I would probably lean towards a CloudFormation template, but for the purposes of the video, we are just going to create a new bucket manually. Let's take a look at that now. Here we are on the AWS console, so we'll start by navigating to the S3 service, going into general purpose buckets and hitting create bucket. Then we're going to give our bucket a name, and we'll copy that to the clipboard for later. We're going to leave object ownership as ACLs disabled. We're going to ensure that public access is blocked, and we're going to enable bucket versioning. OpenTofu highly recommends having versions switched on in order to be able to roll back in the event of a catastrophic failure. We're going to ignore the tags, and we're going to leave the encryption settings as the defaults, and we can go ahead and hit create bucket. And there we can see that our bucket's now been successfully created. As I'm doing this via the web console, I'm just using my admin account to provide access. But for production workloads, you should create a user for this purpose. And the only permissions it should have in order to follow the principle of least privilege are S3 list bucket, S3 get object, S3 put object, and S3 delete object. Now let's jump back to VS Code and look at how we update the Terraform repo to make use of the bucket. Now that we've got our bucket set up, we can go ahead and start updating our Terraform code to support the remote backend. To do that, we need to add in the backend element into our Terraform provider, setting the type to S3 and providing the required configuration, including the bucket name and region, as well as the key under which our state will be stored. We also need to include the AWS CLI profile name we can use to access the bucket. Just like in our introduction video, this can be done by configuring the AWS CLI tool on your machine. Previous versions of OpenTofu required a separate DynamoDB table to manage state locking, but since the 1.10 version, native S3 locking is now supported. To make sure we have this set, we need to have use_lock file set to true. So let's add all that in now. So we'll start with our Terraform module. We'll add in the backend block and we'll set it to S3. And then we can cut and paste some of the config that we have here. And then we need to make sure that our bucket name matches the bucket, that our key, that's where we're going to store it. So state/development, it's in the same region, and the profile, my profile is called Terraform, and there's our lock file being set to true. So we'll save that up. And now we just need to reinitialize the module so that we can run and apply our plan as per normal. So let's go into tofu init. And we can see there that it's successfully installed correctly. And so now if we rerun our plan command, there it is. And now we can run and apply and see if it works. As you can see, the command is now finished running successfully, and if we go into our S3 bucket, we can now see that our Terraform state file is there. So that's it. We've now got OpenTofu writing state into an S3 bucket with proper locking and security, giving us a single source of truth that can be shared across a team or CI/CD pipeline. The key takeaway here is that you don't need to pay for a cloud service just to get reliable remote state. With a little bit of setup, you can own and control the process yourself. If you're just experimenting, local state is fine. But once you're working with a team or running production workloads, moving your state to a remote backend is non-negotiable. It's what keeps your infrastructure changes safe, consistent, and auditable. If you found this useful, hit like, subscribe to the channel, and drop a comment with your own tips or questions about OpenTofu below. Thanks for watching, and I'll see you next time.